to show you our molecule.
Sulfur tetrafluoride.
SF4 stands for sulfur tetrafluoride. It releases dangerous hydrofluoric acid upon exposure to water and moisture. Some compounds are useful in pharmaceutical and chemical industries. The appearance of SF4 is like a colorless gas. It is also hazardous as it's highly corrosive and highly toxic. So, do you want to know more about SF4? Stay tuned!
Hello! Today I will teach you how to draw a Lewis structure. Ta-da!
Let's do the SF4 Lewis structure. But before that, we need to know the valence electron for each element. As you can see here, we got one atom of sulfur, 4 atoms of fluorine, based on periodic table, sulfur got 6 valence electrons, while fluorine got 7 valence electrons. So, for a total, we have 34 valence electrons. To do the Lewis structure, first we put sulfur at the center because sulfur got least electronegative than fluorine. Then put the fluorine around it. All of them is 4. Next, we put bond between atoms. Each bond represents 2 electrons. We have used 2, 4, 6, 8 electron valence. Let's go around the outside. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. And we have filled the octet for everything. And we have 2 valence electrons left over. We can put them right here because sulfur is in the period 3 and it can have more than 8 electron valence.
That's all for Lewis structure. Now, let's continue with formal charge.
The formula of formal charge is valence electron minus non-bonding valence electron minus bonding valence electron divided by 2.
Now, let's calculate the formal charge for the sulfur. The valence electron for the sulfur in the periodic table is 6 minus non-bonding valence electron. It has only 2 non-bonding electron. Non-bonding valence electron for the sulfur is 8. It's because in this bond it has 2 electrons, so it's become 8. 8 divided by 2 equal to 0. Now let's calculate for the fluorine. In the periodic table, fluorine has 7 valence electrons. Fluorine has 6 non-bonding valence electron minus bonding valence electron for the F only 2. We need only to calculate fluorine for once because it has symmetrically, so it's equal to 0. So this is the best structure for the sulfur tetrafluoride.
Okay, let's continue with the shape and bond angle of SF4.
Basic molecular shape of sulfur tetrafluoride is trigonal bipyramidal. The structure of sulfur tetrafluoride drawn below. Two fluorine atoms are present at axial position, while two fluorine atoms are present at equatorial position. The angle between fluorine axial to fluorine axial is 180 degrees, while the angle between fluorine equatorial to fluorine equatorial is 120 degrees, while the angle between fluorine axial to fluorine equatorial is 90 degrees. But there is a presence of lone pair, so the angle will change and the shape will become seesaw. The lone pair occupy the equatorial position because equatorial repulsion are weaker than axial equatorial repulsion. So, the configuration of SF4 is specified by AX4E.
Okay, now I'm going to explain about repulsion process of SF4. In previous explanation, the axial FSF angle will be 180 degree, and the equatorial FSF angles are 120 degrees. Due to the repulsive forces of the lone pair, these are arranged in a trigonal bipyramidal shape with 102 degrees FSF bond angles between the equatorial fluorine atoms and 173 degrees between the axial fluorine. The lone pair take an equatorial position because it demands more space than the bonds. The result is seesaw-shaped molecule. I hope our informations are useful for you guys. Thanks for watching.